Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. We are from Group 9. Will present about experiment equilibrium of rigid body. So these are our team members. So the first one is me, Muhammad Badrul Fahmi bin Mansur. Second is Muhammad Hakimi bin Muhammad Arif. Third, Muhammad Ahmad Haziq bin Muhammad Akmal. Fourth, Muhammad Amir bin Akmal. And the last one, the fifth, Muhammad Haris Haikal bin Muhammad Kamal.
For the agenda, we have 5 items to present it. First, we have the theory, where we will explain the basic principle of static equilibrium and its importance. Second, we will look at the observation and result from our experiment, including the data and finding. Third, we will move to the discussion, where we will compare our experimental result with theoretical value and highlight any differences. The fourth, we will cover the application in real life, showing how this concept apply to structure like beam and bridge. Finally, we will end with the conclusion, where we will summarize what we have learned from the experiment and its relevance. Okay, right now I want to explain more about theory of equilibrium of rigid body. A rigid body in static equilibrium has zero net force and moment. It means the sum of force in all directions and the sum of moments must be zero. This ensures no translation or rotation. The center of gravity is the balance point that keeps the body stable. These principles are key for analyzing structure like beam and bridges. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Muhammad Hakim Arif. So, I was assigned with the observation of equilibrium of rigid body. So, for the observation, before conducting the experiment, we carefully checked that all equipment was correctly set up and calibrated. During the experiment, we observed that the beam achieved equilibrium when the total clockwise movement equal the counterclockwise movement and the net vertical force was zero. Small change in weight or position noticeably affected the balance, emphasizing the need for precise measurement. The beam titled when the force were unbalanced, which helped us understand how sensitive equilibrium can be. After the experiment, we reflected on how our observation matched the theory of static equilibrium and the importance of accurate setup in real-life application. Thank you.
Assalamualaikum, my name is Muhammad Ahmad Haziq bin Muhammad Akmal. I'll be covering the video presentation for result and discussion. As we can see in this slide, there's the result table for our experiment. There's a total of 8 different tests for this experiment. So for the experimental value for RA plus RB, test 1 is 10.4 Newton, for test 2 10.3 Newton, for test 3 14.5 Newton, for test 4 30.8 Newton, test 5 9.5 Newton, test 6 13.9 Newton, test 7 13.9 Newton, and test 8 18.7 Newton. As we see, the value of experimental value and the calculated value isn't the same due to many factors and variables. For discussion, in this experiment, RA and RB represent the reaction forces at the beam support. These focus change depending on the load's position, aligning with theoretical expectations. When the load was centered, both supports share the force equally. When off-center, one support carried more. The total experimental forces RA plus RB was often higher than the theoretical values due to factors like the beam's own weight, friction at supports, and minor measurement errors. These differences highlight real-world conditions not accounted for in theoretical calculations, but overall the results supported the principle of static equilibrium.
So I will continue the presentation. So in this page, we have application in real life. We have 4 examples, which is the first one is bridge construction. Engineer must apply static equilibrium to calculate support reaction and ensure that bridge remains stable under varying load from vehicle, pedestrian, and environmental force. So the second one is crane operation. Crane must be balanced to avoid tipping over. Calculating the moment and force ensure that the load and counterweight are correctly positioned to maintain equilibrium. So I will continue. The third is shaft or beam support in buildings. Wall mount, shelf, or horizontal beams in structures must be properly supported to prevent collapse when loaded. Engineers use equilibrium principles to determine the safe load limits. So the last one is playground equipment design. Designer applied static equilibrium to ensure that seesaws balance correctly when equal weights are placed at equal distance from the pivot, ensure both safety and functionality.
Hi, my name is Muhammad Amin bin Akmal. My matrix number is CD240377. Today I will explain about our conclusion. Our conclusion is the experiment successfully demonstrates the concept of static equilibrium in a rigid body by applying the principle of moment. We were able to accurately determine the support reaction and understand how the position of the load effect balance. Although we counter a minor error, mainly due to misalignment and equipment limitation, the overall results were consistent with theoretical prediction. This highlights the importance of precise measurement and proper setup in such experiment. For future improvement, we recommend using digital tools and better support fixture to exchange the accuracy and reliability of the result. That's all for me. Thank you.
So that's all from our group. Thank you.